Okay. Probability from a more mathematical point of view. Now, what do I mean when I say from a more mathematical point of view? We've talked about probability before, but it was just find the probability of this. Oh, we need the software to do it because it's got to do with some weird calculations. So we're now going to go back and talk about probability in situations where we can actually do the calculations by hand. So we're actually going to be working it out. Okay, so I'm going to start us off with a question. Suppose a family has 2 kids. If one kid is a boy, what is the probability that the other is a girl? One out of 2. Okay, why 1 out of 2? Okay, could be boy, could be girl, so it's 1 out of 2. Does anybody else have a different guess? Sorry? 50%? Is 50% a different guess?
No.
Okay. Okay. So does everybody agree with this guess, or do you have something else? Does everybody agree with this guess?
Yeah.
Okay, Kelly. Oh, okay, right. So for the purposes of these problems,
Like just because there's 2 options.
we're going. First of all, we're going to assume that every child is either a boy or a girl, and second of all, we're going to assume that the probability of having a boy or a girl is 50-50. Just for simplicity. No. Okay. All right. It's sorry? Okay. So let me just say that we will come back and answer this, and I promise the answer will surprise you. In the class. Okay. Alright. So what is probability? Probability measures the likelihood of an outcome or an event. So for example, if you flip a coin, what's the probability that it comes up heads? Alright. 1 out of 2. Is that good?
Yeah.
Okay. What is another way to write 1 out of 2? 0.5. What's another way to write that? 50%. Okay. We've talked previously about why we use each of these different things. 1 out of 2 is sometimes the easiest to write down. 0.5 is the easiest with which to do calculations, and 50% is usually how we talk about it in common language. For the purposes of these problems, we'll probably be using usually fractions, sometimes decimals, if we have to do calculations. Okay. Now, if you roll a die, what's the probability that you roll a 1 or a 2? Okay, is everybody good with that? Okay, 6 possibilities, 2 of them are the ones that we're looking for. Okay, now, what is the probability that if you guess someone's birthday, you're correct? Birthday is month and date. 1 out of 365. Make sense? Okay. And then also, again, for the purposes of this class, for simplicity, we're just going to assume that a year has 365 days. Forget leap years. Okay. So, what is probability? The probability of an event is x over n. So x is the number of ways an event can happen, and n is the total number of possibilities. Okay. So, in some cases, you could also think of this as f over n, where f is the frequency. We'd use that definition earlier in the semester. These all amount to the same thing. Okay. So, for example, in the dice question, when you roll a die, how many total possibilities are there? 6. And in this case, how many of them were we looking for? 2. So the probability is 2 out of 6. Okay. So I think that should be straight. Any questions? Okay, moving on. Oh, sorry. Just a reminder, some of the characteristics of probabilities. A probability value has to be from 0 to 1. And if you have a probability of 0, that's called an impossible event. So an example of an impossible event, what's the probability that you flip a coin and you get blue? 0, can't happen. Okay. Probability equals 1, that's what's called a certain event. So here's an example. If you roll a die, what's the probability that you get something less than 7? Well, the probability isn't 6. 6 out of 6. And what's 6 out of 6? 1. It's a guarantee. Absolutely. Okay. And also, as we've seen, in a given scenario, all probabilities must add to 1. So these are rules that we've been using, but as applied to statistics. Now we're going to use them in general. Okay. Pick a card from a 52 card deck. What's the probability that you pull a king? Yep. 4 out of 52. Okay. Now, who does not know the structure of a basic 52 card deck? Okay, so let's talk about that right now. So the first thing you need to know is that there are 13 what are called ranks. And this goes ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. And how many, so for example, how many kings are there? There's 4. And we'll get to what those four different kings are in 1 second. What from a deck of cards, what's the probability of pulling a heart? Sorry? There you go. It's 13 out of 52. Now why is that? Well, every deck of cards has 4 suits. The suits are spades, hearts, diamonds, and clubs. So for example, we said there are 4 kings. What are the 4 kings? King of spades, king of hearts, king of diamonds, king of clubs. So how many aces are there? 4. What are the 4 aces? Exactly. Now, how many diamonds are there? There's 13. What are those 13 diamonds? Exactly. Ace of diamonds, 2 of diamonds, 3 diamonds, blah, 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 up to king of diamonds. Okay. So, does that make sense? Okay. So now, what's the probability of pulling... Oh, I'm sorry, before we go on. We can simplify these things, by the way. So the probability of king is 4 out of 52, but we could simplify that if we wanted to what? 1 out of 13. And for the hearts, we could simplify that if we wanted to what? I'm going to stick with writing fractions, and you'll see why. So this is 1 out of 4, but you're right, it's also 0.25. So now, what's the probability of pulling a spade?
13 out of 52.
Right. So it's 13 out of 52, or 1 over 4. Now, what's the probability of pulling a spade or a heart? Yes. Why is it? Okay. So on one hand, we can say, yeah, this is 26 out of 52, and how did you get that? Right. 13 spades, 13 hearts. So we're looking for, so this is 13 plus 13 out of 52. because there's 26 total cards. There's another way to think of this problem. The other way is to say, what's the probability of pulling a spade? It's 13 out of 52. What about pulling a heart? And then what can we do? Add them together. But we're going to need this rule, and you're going to see why. So here's what's called the addition rule for disjoint events. So if you want the probability of E or F, it's the same as the probability of E plus the probability of F. Now what do E and F stand for? Well, in probability we use capital letters to represent an event. So in this case, what does E stand for? E stands for I pulled the spade. And what does F stand for? F stands for I pull the heart. E for event, and then alphabetically thereafter. No reason. You can use A and B, I don't care. Alright. So at the end of the day, if you simplify this, you just get a half. Now, what's the probability of pulling a king or a spade? And how did you get that? Absolutely. Do you play cards much? No? Okay. It's very clever. Most people who get that question right away play a lot of cards. I have some experience. Okay, so Chassis is exactly right. How many kings are there?
4.
There's 4. So if I write this in terms of probabilities, it's 4 out of 52. Then how many spades are there?
13.
There's 13. There's 13 out of 52, so we want to add these together. But we made a mistake. If we just leave it here, what did we do?
It's going to be 5 times because there's 1
Right. We have double counted what? We've double counted the king of spades. So what do we have to do to get this right? Exactly, we've got to undouble count it. And how do we uncount something? You subtract. So if you work this out, 4 plus 13 is 17, minus 1 is 16.
Because for the king, there's spade cards, and that 13 cards.
Oh, okay, okay. You put it twice, yeah.
Okay. And this is the king of spades. Kings. Okay. So what we now need to look at is the general addition rule. So in general, if you want the probability of E or F, you have to take the probability of E plus the probability of F, but then what do you have to do? You have to subtract the overlap. Now how do we say overlap in math? We say probability of E and F. And the way to interpret and in math is that it means the overlap. It's both a king and a spade. Okay. You dig? Alright. Now just a quick comment. Why didn't we have to do this in the previous problem, probability of spades or hearts? Right. There's no overlap, so we didn't discount. So we didn't double count anything. So there's nothing to subtract. Make sense? Okay. Next, what's the wait. Okay. What is the probability that we pull not a heart? I want to stretch this out. Okay. All right. So what's the probability we pull not a heart?
39 out of 52.
Okay, and how do you get 39 out of 52?
13 minus 52.
Sorry?
13 minus 52.
Yeah, 52 minus 39. Right. Okay. So one way to look at this is to say, well, I've got how many cards are not hearts? So there's 39 out of 52. And you can simplify that. By the way, what does that simplify to? 3/4. There's another approach to this problem. The way to figure out 39 is to say, well, there's 52 cards and 13 of them are hearts, so I'm going to take that away. But let's extend this further. Let's talk about this in terms of probabilities. What's the total probability? The total probability for everything
1.
is 1. Now we want to take away the hearts. What's the probability for the hearts?
13.
It's 13 out of 52. But it's going to be useful, as we're going to see. And in fact, let's simplify all these things. If you simplify 13 over 52, remember from before, what did we get? It's just 1 out of 4. So the probability of pulling a heart is 1 out of 4. So when you take 1 minus 1 over 4, what do you get? What's 1 minus 1/4? What's 1 take away 1/4? 3/4 or 0.75. So doing it this way should look familiar. What does this remind you of? If the probability of having a heart is 1/4, the probability of not having a heart is 1 minus 1/4. When have we done something like this before? Yeah, what did we do on the graphs? Yeah, 1 minus. 1 minus gives you the probability for everything else. And that's exactly what we're doing here. Now we're just doing it, but we're doing it not just on the graph, we're doing it for in general. Okay. So this is called the complement rule. So complement is the same as not. It's also the same as everything else. Okay. So what is the notation for this? Well, there are 3 different notations. I think the middle one is the one used most of the time in the text, but just in case I put all 3. So if E is your event, then the opposite of that, or not, or complement, you could write it as E bar or EC or squiggle E or tilde E. I think EC is the one that's used in the book. The reason C again stands for complement. Me too. Okay. All right, so any questions about these things? Okay. Okay, so let's get on to it. Okay, so next bit, finding probabilities from real world data. So the first thing is, let me blow this up so you guys can read a little better. Okay. So the first thing is, I want to make sure that we can understand what this table says. How many women have never been, how many women are married? 62.8 million. Okay. How many people in the United States have never been married? Y'all?
9.
51.9 million. Just want to make sure someone within Albana gets it. Okay. Now, how many total people in the U.S. are covered by this study? 212.5 million. Okay. Does everyone catch this?
Is this true?
Yes. This is from the U.S. Census. I'm not sure. One of the last two censuses, I would imagine. United States, yeah.
I second wrong. I thought it was worse than 1.7.
Wait, how come 12.7 million women were divorced and only 9 million?
How's it? I'm sorry?
That only 9 million men divorced.
Okay. So, just, again, it doesn't matter for our calculation purposes, but just to understand this in the real world, I presume that they mean currently divorced at the time of the study, not ever divorced. Right? Okay. So if you got divorced and married again, presumably your current status is married. So maybe that makes more sense. Alright, so now, what's the probability that a person in the US was never married? There you go. 51.9 out of 212.5. Notice that we don't need to write out all the zeros, we can just do it like this because it'll cancel. And now we need to figure out what this equals. Okay. Oops. 51.9 over 212.5. So that gives you, oops. Okay. 0.2442. Okay, next. What is the probability a person in the US was widowed? Equals, I'm sorry? Why 14? Right. So 14 over 212.5. And that's 0.0659. Now, what's the probability a person in the US is not widowed? So the long way would be to add everything else up and then divide by 212.5. What's the short way? 1 minus.
Oh, yeah.
Right. Yeah. 1 minus what? 0.0659. So Chastity, this goes back to what you were asking about before, where it seemed longer. Is this longer or shorter? Using this is much quicker. And if you work it out, you get 0.934. Okay. So does that make sense? Okay. So now there's a couple problems for you guys to do. So take a minute and work on these. Alright, so let's talk about these problems. So, first one, Madeline, what's the probability of a jack or a 10?
I still have some.
Okay, somebody.
8 out of 52.
Okay, so how do you get 8 out of 52? 4 jacks, 4 tens, 8 out of 52. And if you simplify this, what do you get?
1, 2,
Long story short, you wind up with 2 out of 13. And if you want to, actually, let me just say, you don't have to simplify it, and you can also write it as a decimal. And if you do it as a decimal, 0.153. And again, I put or to indicate that if you put any of those answers, it's fine. Okay. Now what about the probability of a 2 or a 3 or a heart? Okay, and how did you get that, Josh? Yes. So you're quite right, but I want to do it in a sort of more general way. The way I want to write it down in a way that'll always work. So how many 2's are there?
4.
So if you write it down, it's probability 4 out of 52. How many 3's? 4, so it's 4 out of 52. And how many hearts? 13 out of 52. And now I want to do what you were saying. So we double counted 2 cards, so minus 2 out of 52. Okay. Which 2 cards did we double count? The 3 of hearts and the 2 of hearts. Okay. So anyway, so you work this all out and you get 19 out of 52.
I don't get it. She doesn't think that she doesn't understand the step of cards. Could you do it? So, you gotta
Okay. So, do you understand how many 2's there are? Do you understand how many 2's there are on a deck of cards?
No.
Okay. Well, that's the problem. Okay. Okay. So let's go back to this briefly because we got some other things to do. Okay. How many aces, how many 2's, how many 3's, how many 4's are there?
4.
There's 4 of each. What are those 4 cards? Right. So for each rank, there's an ace of spades, ace of hearts, ace of diamonds, ace of clubs. Similarly, how many hearts are there? What are those 13 hearts? Ace of hearts, 2 of hearts, 3 of hearts, blah, 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 up to king of hearts. Now, when we work on this problem, so we say, what's the probability of pulling a 2? There's 4 2's, so it's 4 out of 52. Probability of pulling a 3, there's 4 3's, so it's 4 out of 52. Probability of pulling a heart, there's 13 of them, so it's 13 out of 52. But what's the problem? We double counted some cards. Which cards got double counted? The 2 of hearts and the 3 of hearts. Does that make more sense? Okay. If you do it that way, it's fine. Yeah, that's fine.
Is this
Okay.
part of this thing again?
More or less.
Really?
Okay. Now, what's the probability that someone is born on the weekend?
Is the weekend Friday, Saturday?
Do we?
Saturday.
What's the weekend? Saturday and Sunday. So what's the probability that someone is born on a weekend?
Is it 56?
I think I heard someone say the right answer. It's 2 out of 7. Oh, that's so clever. This usually takes a long time.
Because I've been thinking about the whole year.
Yeah.
Hello? You gotta be more...
And that's the trick,
Yeah,
right? Most people try to figure out of a year how many days are weekend days. But that's hard. But that's, first of all, not only is it hard, it's impossible for this reason, because how many weeks are in a year? It doesn't vary. How many weeks are in a year doesn't vary. It's 52 weeks plus a day, and that plus a day is the problem. No, because 52 weeks is 364 days.
Oh, okay.
So a year is not exactly 52 weeks. So trying to figure this out is actually a problem. Okay. So what some people clearly figured out is that what's the right way to think about this question, not in terms of a year, in terms of a week. And when you say in terms of a week, clearly it's 2 out of 7. Okay. This is one of those answers that as soon as you say it, it's obvious and easy, right? Okay. Okay. So, right. So don't do it this way. Okay.